Hello again. In this video I will try to learn about the shell scripting in general, and we will actually look all of the important things that can be asked in a job interview related to the shell scripting. So like a shell script is a computer program designed to be run by the Unix or Linux shell, which could be one of the following: the Bourne shell, which basically the bash, which we can see with the ps command, so which means that our terminal is the Bourne shell, the C shell, the Cron shell, and GNU Bourne again shell, and Bourne again shell, actually R shell. So shell scripts have several required constructs that tell the shell environment what to do and when to do it. Of course, most scripts are more complex than the above one. The shell is, after all, a real programming language, complete with variables, control structures, and so forth. No matter how complicated the script gets, it is still just a list of commands executed sequentially. The following script uses the read command, which takes the input from the keyboard and assigns it as the value of the variable person and finally prints it on standard out. So, for example, from the previous video, we have created a file called sample directory, and in this directory we put a test.ch file. So let's open this test.ch file. Here, as you can see, we indicate that this is actually a shell file, and it's ready for execution. So we output on the screen what's your name, and we read a variable called person, and we echo what we read. So, and as you can see, let's get out, quit, and when we execute this shell command, it asks our name. Let's say, and I put my name, and it puts on the screen. And so, in detail, a shell provides you with an interface to the Unix system. It gathers input from you and executes programs based on that input. When a program finishes executing, it displays that program's output. Shell is an environment in which we can run our commands, programs, and shell scripts. There are different flavors of a shell, just as there are different flavors of operating systems. Each flavor of shell has its own set of recognized commands and functions. So, for example, this is as you can see, we have the command prompt here, and let's say the date. As you can see, we can get the date. Example of the date command: the Bourne shell. If you're using a Bourne type shell, the dollar character is the default prompt. This is the Bourne shell, basically bash. If you're using a C type shell, the percentage character is the default prompt. So the different C type shells follow. The original Unix shell was written in the mid-1970s by Stephen R. Bourne while he was at the AT&T Bell Labs in New Jersey and stuff. So Bourne shell is usually installed as bin sh on most versions of Unix. For this reason, it's the shell of choice for writing scripts that can be used on different versions of Unix. The basic concept of a shell script is a list of commands which are listed in the order of execution. A good shell script will have comments preceded by the what was the name of this sign? Let me check the name of. I always forget this sign, actually. It's like it's the number sign. Yeah, it's number sign. So anyways, so it's the number sign describing the steps. There are conditional tests such as value A is greater than value B, loops allowing us to go through massive amounts of data, files to read and store data, and variables to read and store data, and the script may include functions as well. So, for example, assume we create a test.sh script. I have created it previously. Not all the scripts would have the .sh extension. Before you add anything else to your script, you need to alert the system that the shell script is being started. This is done using the shebang construct. For example, this is the shebang construct. This tells the system that the commands that follow are to be executed by the Bourne shell. It's called a shebang because the number sign symbol is called the hash. This is the hash symbol, actually, yeah. And the exclamation symbol is called the bang. So shebang, basically, hashbang. To create a script containing these commands, you put the shebang line first and then the commands. So, for example, where is this file? We have the other one is not open yet. vtest.ch. So let's get rid of all of these, and let's say we want to see the current working directory, and we want to list, and let's w and c. Now when we test.ch, as you can see, now we see that we are in the sample directory, and in this directory we have the files sample underline file.txt and the test.shell. So we can actually, so let's open this test.ch again. Shell comments. You can put your comments in your script as follows. So to put comments, you basically need to put the number signs. So we are in insertion mode now. This is a comment. And when we get out, this will not change anything. So normally when you want to execute the shell file, you need to make this file executable. So you need to tell, so right now, normally when you create the shell file first, this file is actually not executable. So you need to change the ch mode, and you need to add the executable to this test.sh. So let's take this. So when you want to execute this, now as you can see, when I press the tab button, it doesn't actually auto complete the file's name in the terminal. So what we need to do is actually, with the chmod command, we need to make this file executable, and when you now you can execute this file. So, and upon execution, you will receive the following result. So now this is the directory, and this is the files inside the directory. I mean, to execute a program, like we all know from the C++ programming, like when you create an executable file, when there is an executable file, you just need to execute it like that, dot followed by a slash and the name of the program, which is usually an output file, .o file in C or C++. And so extended shell scripts. Shell scripts have several required constructs that tell the shell environment what to do and when to do it. Of course, most scripts are more complex than the above one. The shell is, after all, a real programming language, complete with variables, control structures, and so forth. No matter how complicated the script gets, it's still just a list of commands executed sequentially. So I have done this example previously, so I will just skip it. In this chapter, we'll learn how to use shell variables in Unix. A variable is a character string to which we assign a value. So a variable is a character string to which we assign a value. They are basically like a string of characters. There's so for example, let's see. The value assigned could be a number, text, file name, device, or any other type of data. A variable is nothing more than a pointer to actual data. The shell enables you to create, assign, and delete variables. Variable names. The name of variable can contain only letters A to Z or capital A to Z, numbers 0 to 9, or the underscore character. By convention, Unix shell variables will have their names in uppercase. Variables are usually in uppercase in Unix shell. The following examples are valid variable names. So these are all possible variable names. It can start with the underscore, underline. Following are the examples of invalid variable names. The reason you cannot use other characters such as exclamation mark, the asterisk or minus is that these characters have a special meaning for the shell. Defining variables. variable name, variable value. Like for example, where is our file? When we open this v.test.sh, let's get rid of these commands. So for example, let's say we have a name Kaan Karagioğlu, and the above example defines the variable name, and then for example another variable, we can have variable 1, or we can let's get rid of this. Let's get rid of this, and let's say this is variable 1, right? This is variable 1, and variable 2 maybe like let's say 28. And now to access this, we just need to echo it, like echo and the sign of the dollar sign, actually, yeah, it's here, variable 1, and echo dollar sign is here, variable 2, and then we saved it and get, now as you can see, we can display this output on the terminal. And what else? Read-only variables. Shell provides a way to mark variables as read-only by using the read-only command. After a variable is marked read-only, its value cannot be changed. For example, the following script generates an error while trying to change the value of name. So name right now is read-only. You can, like, let's v.test.sh again. Now, so we have these variables, and after that, and after we have actually defined, after we initialize this var2 variable, we can say read only var2, and now when you actually try to change var2 to 30, let's say, let's var2 not found. I mean, let's try to understand the reason. We have our variable 1 and variable 2. We made the variable 2 read only, but variable 2 after this point, is this the same thing? So how we was using Control R. So like we have a name, read only, variable 1, and now you want to make this var1, variable 1, something else. So now you want to change the content of the variable, but when you execute it, var1 is read only, so it doesn't allow this variables. It doesn't allow the variables value to be changed. So okay, unsetting the variables. Unsetting or deleting a variable directs the shell to remove the variable from the list of variables that it tracks. Unsetting or deleting a variable directs the shell to remove the variable from the list of variables that it tracks. Once you unset a variable, you cannot access the stored value in the variable. Following is the syntax to unset defined variable using the unset command. So after you define something, like this one, it's a read only, and when you unset it, unset variable 1, now at this point when you want to echo it, this is an error. var1 is read only. Read only you cannot change, but now I suppose the error is going to be different. Yeah, because it doesn't exist. there's no error, but we unset the variable. In the meantime, I'm having a coffee. And so variable types. When a shell is running, three main types of variables are present. Local variables. A local variable is a variable that is present within the current instance of the shell. It is not available to programs that are started by the shell. They are set at the command prompt. These are local variables. It's a variable that is present within the current instance of the shell. It is not available to programs that are started by the shell. They are set at the command prompt. Environment variables. An environment variable is available to any child process of the shell. Some programs need environment variables in order to function correctly. Usually a shell script defines only those environment variables that are needed by the programs that it runs. Shell variables. A shell variable is a special variable that is set by the shell and is required by the shell in order to function correctly. Some of these variables are environment variables, whereas others are local variables. So basically, local variables is a local variable is a variable that is present within the current instance of the shell. Like, for example, when you open a terminal, a local variable is only current instance. This variable's value is only available inside this terminal. It's not available to programs that are started by the shell. It's not available to programs it's not available to the programs that are started by this terminal. So they are set at the command prompt. Environment variables, however, is available to any child process of the shell. So when you create an environment variable, all of the programs or softwares that have been executed from the shell also have coverage, also has the same variable. Some programs need environment variables in order to function correctly. Usually, a shell script defines only those environment variables that are needed by the programs that it runs. Shell variables. A shell variable is a special variable that is set by the shell and is required by the shell in order to function correctly. Some of these variables are environment variables, whereas others are local variables. In this chapter, we will discuss special variables. In one of our previous chapters, we discussed how to be careful when we use certain non-alphanumeric characters in variable names. For example, the local character represents the process ID number or PID of the current shell. So, for example, when you run echo of ... and now what is 68,105. So what is this? So this is the process ID. So you echo process ID of our terminal. How we can check that? How can we check that? So open, let's say PS. This terminal's process ID is different from the previous one. But here, when you check, as you can see, this process ID is the same with what this actually command returned. Anyways, let's close this. The following table shows the number of special variables that you can use in your shell scripts. The file name of the current script, as you can see, let's close this, and we only have this one. Okay, so for example, you want to echo, you want to see on the screen of what? You want to see the file name of the current script, which is bash, right? And the file name of the current script. So if you want to actually put this inside the test.sh, let's get rid of this. You want to echo of this. Now when you execute this, as you can see, it actually returns the file name of this script. These variables correspond to the arguments with which a script was invoked. And is a positive decimal number corresponding to the position of an argument. The first argument is this, and the second argument is this, and so on. So for example, let's open our test.sh file. So echo 1 and echo 2. and close it. So now these variables correspondent to the arguments with which a script was invoked. So for example, I want to invoke this test.sh with two things, let's say me and you. So as you can see now, I put these me and you on the screen because I echoed them here in my bash file, in my sh file. And what else? The number of arguments supplied to a script. Again, when you open this file and when you change this with, for example, with a number sign, and then let's close this, and then when we execute this, let's say with 1, 2, 3, 4, and 5. With 5 arguments, we have, as you can see, 5 here, excluding the sh file here. So anyways, let's clear here a bit, and then we have all the arguments are double quoted. If a script receives 2 arguments, is equivalent to they are double quoted. So for example, all arguments are double. If it's equivalent to okay, so then let's see what it does. So we want to put this one, right? And now if this receives these one, or maybe it receives these ones, double quoted. Yeah, it basically doesn't print, it doesn't put the file name, because previously, like this is the number of arguments, like this. Wait a minute. It basically puts the number of arguments without this one. All the arguments are individually double quoted. If a script receives 2 arguments, is equivalent to all the arguments are individually double quoted. So the exit status of the last command executed. And now the exit status is 0. The process number of the current shell for shell scripts, this is the process ID under which they are executing. So when you want to change this file and when you want to echo this process ID of this, what's going to be the process ID here? But when you check with the ps command, this process ID and this process ID is not the same. So what's happened? Because basically this process, this ps process is this one. They are different processes. This is like a child process then. So when you basically show the process of this shell script, it shows another process. But if you, for example, if you echo this here inside our terminal, you will get the correct, you will get the process ID of our terminal. So, but this will reveal another process, which is the child process of our terminal. Command line arguments. The command line arguments are positional parameters with 0 pointing to the actual command, program, shell script, or function, and are as the arguments to the command. So now let's open a new command line. Let's say command line arg.shell, and let's echo file name. As you can see, the file name is this one. We can yank with Y, I press 2 times Y, I can come to the previous one and I press P. Now when you press P here in the second line, what's going to happen is that it will put the line one line after the place that you passed it. You passed it, the yanked line. So let's get rid of it, and you press 2 times Y, and then in this place you press P, and now it puts here. So these are really tricky stuff that people get, like you get used to it after some time. First parameter is basically this one. Again, yank it and copy it. We can copy as much as we want. Quit. Yes. 0, 1. This is the second parameter, of course. Second parameter. We can press R or C, R2 to replace it. And quoted values. Quoted. What was the quoted? It's basically this at. This is the same. Quoted with the asterisk, $sign and the asterisk, and the total number of parameters. Total number of parameters, and this is gonna be yes. So now when you actually, but we need to put the shebang here. We need to put the shebang bin.sh and close it. Now if you want to execute this, you cannot. So you actually need to make it executable with chmod plus X, and this is the file that you want to make it executable. And now you can use this one. We didn't call any parameters, so I can basically give my name. So first parameter, second parameter, quoted, and the unterminated quoted string. So in line 12, so unterminated quoted string. It's not yeah, as you can see, this is unterminated. And yeah, not total number of parameters, it's 2. It gives unterminated string error when you don't put this, when you don't put the double quote symbol. Special parameters, $, asterisk, and $at. There are special parameters that allow accessing all the command line arguments at once. These are both will act the same unless they are enclosed in double quotes. Both the parameters specify the command line arguments. However, the $, asterisk special parameter takes the entire list as one argument with spaces between. And special parameter takes the entire list and spaces separates it into separate arguments. So we can write the shell script as shown below to process an unknown number of command line arguments with either the $, asterisk, or $at special parameter. So for example, let's open this. Let's say now, let's make a directory, not make a directory. Let's open a different file called for bash.sh, let's say. And here, let's put the shebang bin.sh for token in. Now this is the, what was this? This is the quoted parameters, right? They are the quoted values. For token in this, we need to echo echo what this token is, and then done. Now when you get rid of it, this one, chmod plus x for bash.ch. Now we execute this with, let's say, Kaan Karalioglu, 28 years old. As you can see, it puts Kaan 20 years old on the screen. For these quoted parameters, it prints them one by one. But when you actually make this like this, now let's see the result. I changed it, right? We have the same output. Here do done is a kind of loop that will be covered in a subsequent tutorial. We like the same unless they are enclosed, unless they are enclosed in double quotes. There are special parameters that allow accessing all the command line arguments at once. Both will act the same way unless they are enclosed in double quotes. Both the parameters specify the command line arguments. However, this special parameter takes the entire list as one argument and with space between. Special parameter, however, takes the entire list as one argument with space between, and takes the entire list and separates it into separate arguments. So, but if we don't have any double quotes, they are basically the same thing. But if we have the double quotes, this one takes the entire list as one argument with space between, and this one takes the entire list. So we can actually see if it is really like this way, and like this. Now it should be a string with spaces between the words, right? Yeah. So, but this then is this takes them separate. So, for example, okay. Takes the entire list and separates it into separate arguments. So in this case, these are the separate arguments. The $sign quotation mark variable represents the exit status of the previous command. Exit status is a numerical value returned by every command upon its completion. As a rule, most commands return an exit status of 0 if they were successful and 1 if they were unsuccessful. Some commands return additional exit statuses for particular reasons. For example, some commands differentiate between kinds of errors and will return various exit values depending on the specific type of failure. Following is the example of successful command. So you echo it and it's actually exited normally. So in this chapter, we will discuss how to use shell arrays in Unix. A shell variable is capable enough to hold a single value. These variables are called scalar variables. Shell supports a different type of variable called an array variable. Shell variable is capable enough to hold a single value. So for example, if these are all scalar variables, shell supports a different type of variable called an array variable. This can hold multiple values at the same time. Arrays provide the method of grouping a set of variables instead of creating a new name for each variable that is required. You can use a single array variable that stores all the other variables. So for example, clear the screen. Let's say we variable types.ch, and we have, let's say, name 1, name 2, whatever, name 3, whatever, 2, something like that. Suppose you're trying to represent names of various students, like you can basically initialize them like this. You can use a single array to store all the above mentioned names. Following is the simplest method of creating an array variable. This helps assign a value to one of its indices. So basically, instead of creating a variable for every student, you can just name of the array. What's the name of the array? 0. And the value, right? Name 1 Hans, let's say. Name 2 let's say whatever, different names. So now now we can echo these. How we echo these? We should not forget the shebang here. sh. Yes, and here we echo the first index, right? And we echo it with what? We need to put this $, the index of the variable, and you need to close it. Let's yank this line here like this, and let's close it. Let's make it executable. Not found. Bad substitution. What we did wrong. I don't know what I did wrong here. Not found, not found, not found. Name 0, name 1, and name 2. Yeah, but they are here. Aha, we need to initialize it, right? After you have set any... Okay, we need to initialize it. So how are we initializing it? Array name, name. I hope this is gonna work. Unexpected. So I need to actually ask this because so you can basically ask how to initialize this array. Remove the comments between the array elements. Changes made, removed the commas between array elements. Aha, there should not be comma between the array elements. So we need to get rid of these. It's insertion mode. y. Kept the elements separated by spaces. I mean, this should work, but syntax error. Okay, so the problem is, it's so funny, but I don't have a, yeah, I need to, so you need to actually, to rename a file, you use, I mean, someone expect, you expect that the name of the renaming a file should be like something like rename, or, but actually move command in the same directory does it. Like, for example, variable type ch, I want to rename this as sh. Now when you check, it's like variable types.sh now. So now we know variable types.sh. Let's see variable types.sh. Read write executable, read write executable. Yeah, it's executable. And syntax error in line 4. I really don't know the reason this should work. Ctrl Alt V. Now it works, but it's basically the same thing. There is no difference. I think the problem was related to the shebang. So anyways, the following result. You can access all the items in an array in one of the following ways. So let's find all of the names. Instead of echoing for the first index with the $sign and name 0, name 1 and name 2, you can actually, we can use something like this name but you need to echo it. So not in insertion mode. Let's go to the beginning and we need to put here echo. This is our first method. Go to the end and close it. Yank it, past it. This is going to be the second one. Now when you type variable types.sh, first method also prints the same, the second method also prints the same. And let's look at the next page. There are various operators supported by each shell. We will discuss in detail about the Bourne shell, the default shell in this chapter, arithmetic operations, relational operators, Boolean operators, string operators, file test operators, etc. So I'm still recording, I suppose. Yep, I'm still recording. And let's open our file again. this is the previous one. Let's make another directory. Let's make another file v, and what's the name of it? Basic operations, operations.ch, and we need to put the shebang bin sh. And here we have a value, expression 2 plus 2, and echo total value is basically this val chmod plus x basic operations. Total value, val is this expression, right? But it's not doing it. In my case, it's not doing it. XPR there must be spaces between operators and expressions. There are spaces between operators and expressions. For example, it's not correct. It should be written as 2 plus 2. The common expression should be enclosed in called the backtick. Aha, that's the backtick. It's not the quote. It should be the backtick. This one. The backtick. Okay, now let's try it. Total value is 4. Arithmetic operators. The following arithmetic operators are supported by the Bourne shell. Assume variable a holds 10 and variable b holds 20. Addition is basically adds values on either side of the operator. So this gives 30. So let's see that basic operations cont.sh, let's say our first variable a, insertion mode a is let's say a is, we want to assign a value, right? So let's say it's 20. There should be an example here. This is the expression 2 plus 2, but we don't need the expression in the first case. So but for example, if you have b like 30 and 30, and I want to echo expression a plus b, this should return 50. Cont. But it doesn't return it. It returns, this should be backtick, let's say. Let's make it backtick. Now let's try it. See this missing argument after plus. So let's say we don't have this here. Now we have. So while defining the variables, we don't need this backtick, but with echoing and with evaluating the expressions, we need this backtick. So subtraction is the same. We can basically have like something 70, 30. Yank it, past it, yank it, past it. And now we have the subtraction. That's multiplication and division. And yank it, past it. The modulus. It's not the modulus. Assignment. This is going to return 0. Or an error, I don't know. Equality. This will probably return 0. And this will gonna probably return 1. So let's see. Should have one space. So 2. So first is, what was the values? 70, 30, 100. 70 minus 30, 40. And multiplication had an error, unexpected argument. Multiplication had their error. Multiplication had an error because it's the asterisk symbol. Asterisk symbol has a different meaning, so we need to have this escape character to be able to get rid of this error. And then now we have it. The modulus 70, 30 modulus. So how do you check 70, 30 modulus? 70 and the 30 mod 30, right? So how many times, how many times 30 is inside 70? So it's 2 times. And yeah, that's the modulus, right? So for example, we get 5 mod 3. Where is this modulus? 5 mod 3. So yeah, is it 2, right? Yeah. So you can check actually. We can check actually with let's say we have 2 variables called C and D. Let's say C equals 3 and let's say C equals 5 and D equals 2. Now you can echo this with the back tick. You can say like A mod B. Now you can see that what was that? Not AB, it should be CD, right? Replace it with C. Come here, replace it with D. And close it. As you can see, it's 1. So modulus is actually 70, 30 modulus. Wait. 70 mod 30. Yes. This should give 10. Yes, it gives 10. Yeah. Anyways, relational operators. So actually there are a lot of stuff here. I think this is maybe just the entrance of I mean, it's, I think, a really good start of learning about the bash scripting. So from now on, I think you can from now on I can actually learn easily. Anyways, thank you for watching my video. See you in the next tutorial video. So if you enjoyed the video, please subscribe my channel, and see you soon. Bye bye.